Need to wrap a GitHub client method as an AI tool without writing boilerplate wrapper functions. You'll see how to transform a raw client method into a polished AI tool in just a few lines, keeping all implementation logic in the original client while adding clear descriptions for LLM-friendly usage. From FastMCP, import FastMCP. From FastMCP tools, import tool. From FastMCP tools tool transform, import ArgTransform. MCP equals FastMCP, GitHub tools. Hash wrap a client method directly as a tool. Get repo tool equals tool from tool. Tool equals tool from function. FN equals GitHub client. Get repository. Description equals get basic information about a GitHub repository. Transform args equals owner. ArgTransform description equals the owner of the repository. Repo. ArgTransform description equals the name of the repository. MCP. Add tool get repo tool. This demonstrates the tool transformation pattern, a declarative approach for adapting existing functions into AI-ready interfaces. The concept revolves around wrapping raw functionality with metadata layers, rather than rewriting or subclassing. What makes this distinctive is its ability to modify argument schemas, descriptions, and behavior without altering the original implementation. The pattern works by creating transformation layers that intercept calls, apply modifications, and delegate to the original function. It follows a composition over inheritance principle, where each transformation is a discrete step that can be chained or reused. The framework handles schema generation from type hints, while your transformation logic remains focused on interface concerns rather than implementation details. This approach solves the common problem of API mismatch between backend systems and AI consumers. Instead of writing boilerplate wrappers for each client method, you define reusable transformation rules that maintain a single source of truth. It's particularly valuable when integrating third-party clients or legacy systems, where you need to present clean interfaces while preserving the underlying functionality. The trade-off is a slight indirection cost, but the maintainability benefits outweigh this for most integration scenarios. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI callable toolsets. It handles tool registration, argument validation, and AI model integration in one interface. From FastMCP tools, import tool. This imports the tool class FastMCP's core abstraction for wrapping Python functions as AI callable tools. It handles schema generation, argument validation, and exposes the function to the MCP server. From FastMCP tools tool transform, import ArgTransform. This imports ArgTransform, a utility for customizing tool argument schemas. It lets you add descriptions, validation, or transformations to individual parameters, making tools self-documenting for AI models. MCP equals FastMCP, GitHub tools. This initializes the FastMCP controller, the central orchestrator for AI callable tools. The GitHub tools string names this toolset, enabling clear separation when combining multiple tool collections. Without this, tools would execute in an unmanaged context, risking state conflicts. Hash wrap a client method directly as a tool. Get repo tool equals tool from tool. This creates a tool wrapper using FastMCP's composition pattern. Instead of exposing the raw GitHub client method directly, we're wrapping it to add metadata and argument transformations, which enables better AI integration and parameter documentation. The FromTool method allows chaining tool transformations while maintaining the original function's core behavior. Tool equals tool from function. fn equals GitHub client. Get repository. This converts the GitHub client's getRepository method into an AI callable tool. The from function factory handles the transformation, preserving the original function's signature while making it compatible with FastMCP's tool system. It's the standard pattern for exposing existing methods as tools without rewriting them. Description equals get basic information about a GitHub repository. This defines the tool's human-readable description that AI models use to understand its purpose. Clear descriptions improve tool selection accuracy and prevent misaligned AI calls by eliminating ambiguity about what the function actually does. Transform args equals. Transform args customizes the tool's argument schema for AI models. It maps Python parameter names to human-readable descriptions and validation rules, ensuring the AI understands and uses the tool correctly. This pattern bridges raw function signatures with AI-friendly interfaces. Owner. ArgTransform description equals the owner of the repository. This applies ArgTransform to the owner parameter, explicitly defining its description for AI tool schemas. The description becomes part of the tool's metadata, ensuring AI models understand the parameter's purpose when calling this tool. This pattern standardizes parameter documentation across all FastMCP tools. Repo. ArgTransform description equals the name of the repository. This defines an argument transformation for the repo parameter, specifying its description for AI tool schemas. The description becomes part of the tool's metadata, enabling proper documentation and validation when AI models call this tool. This pattern ensures all parameters are explicitly defined, preventing ambiguous or undocumented inputs. This closing brace terminates the transform args dictionary definition, finalizing the argument transformations for the GitHub repository tool. It ensures all parameter descriptions are properly encapsulated before being passed to the tool constructor. Closing parenthesis terminates the getRepo definition. This finalizes the tool configuration, including its transformed arguments and description, making it ready for registration with the MCP instance. MCP, add tool getRepo tool. This registers the tool with the FastMCP instance, making it discoverable and callable by AI models. Without this step, the tool exists but remains inactive in the system. The pattern mirrors how web frameworks register routes before they can handle requests. Tool transformation pattern. The ArgTransform system in FastMCP 2 creates AI callable interfaces by wrapping existing client methods without duplicating implementation logic. Hidden arguments with defaults automatically handle internal parameters, keeping them invisible to the LLM while preserving functionality. This approach maintains a single source of truth while exposing only the relevant interface.
The argument that vanishes from the schema remains present in the call.